Okay, this is exam 2 for Physics 102. Just a reminder that when you're doing your N number, to please write your N number. Um, and then I want you to bubble it as well and recognize that the zeros are the first number, and then it follows 1 through um, 0. And often if you have a 1, students will sometimes bubble the 0 instead of the 1. So make sure you're bubbling that correctly. And then also, please always remember to sign your honor statement. Your honor is very important to me, and it's very important to you, and it's very important to Nichols. So please make that pledge to me that you will remain honest in taking your exams and have your equations on there. So let's start with the free response. What is the potential at point A? So to find the potential, I do the sum of all the individual potentials. So that's going to be V1 plus V2 plus V3. And then that's going to be K. I'm going to go ahead and put the numbers in. 9 times 10 to the ninth times Q1, which is 8 times 10 to the minus 9 coulombs. And then this distance is 4 meters. So it's divided by 4 plus 9 times 10 to the ninth. Q2 was 5 times 10 to the minus 9 over 5 meters plus Q3 was 6 nanocoulombs divided by 6 meters. I think, wasn't it 6? Oh no, 3 meters, excuse me. And so if I add all those, recognize this one is negative too, by the way. I can do some cancellations out here. Sort of makes this a little easier. Leaves a 3. That leaves a 2, so that is 18 plus 9 minus 18. That's equal to 9 volts. So the potential at point A is 9 volts. And if I move a proton from a far distance away to point A, how much work is required to do so? So in order to do that, say I'm taking a proton from over here, where the potential initially is equal to 0, and then I move it over here, where the final potential is equal to 9. The work is equal to Q times delta V. That is 1.6 times 10 to the minus 19 coulombs times delta V, which is going to be the final potential minus the initial potential. And so that's going to be equal to 1.4 times 10 to the minus 18 joules. All right, so that's that answer, and that's that answer. Now, let's do this circuit. Now, in order to do this, first thing you want to do is redraw it. And so I'm going to start here and go through. There's my 12-volt battery. Let's see, I'll do it in the same orientation. 12-volt battery. There's my 2 microfarad. And then I come to a parallel branch right here. It breaks into 2 parts that then come back together right here. So and then that's going to be 4 microfarads and 2 microfarads. And then I have another parallel branch that goes here, and then comes back together. So it only has 2. In the top branch I have 1, and then in the bottom I have 2 capacitors. That's 1 microfarad, and then 4 and 4. And then I go back to my battery of 12 volts. Okay, so I want to find the equivalent now. To find the equivalent, I find the equivalent first of this, a 4 and a 4. That's 1 over a quarter plus a quarter. That's 2 microfarads. The equivalent of this is 4 plus 2 is 6. So I have 3 capacitors here. I have 2, 6, and 3. I didn't do that. I have 2 plus 1 is 3. So that's 3 microfarads, 6 microfarads, and then 2 microfarads with a 12-volt battery. If I do 1 over 3 plus 1 over 6 plus 1 over 2, that's equal to 2 6 plus 1 6 plus 3 6. That's 6 6. That's equal to 1. So the equivalent capacitor here is a 1 microfarad capacitor. So that's the answer to that one, 1 microfarad. But then if I want to find the voltage on C2, let's see, C2 is this capacitor right here, one of those 4 microfarad capacitors. Now, you know, I first want to figure out what is the charge. Oops, sorry here. This is 12 volts. That means that this has a charge of 12 coulombs. That means each of these have charges of 12 coulombs because they're all in series. And then I can find the voltages for each one. The voltage is going to be equal to Q divided by C. So that's going to be 4 volts, 2 volts, and 6 volts. All right, so I can step that back. Let's see, I'll go to a different color here. This one is going to have 4 volts. These will both have 2 volts. The reason they have 2 volts is they're identical capacitors, and so they split it up evenly. By the way, that's my answer is 2 volts. Let's go ahead and do the others though. This is 2 volts here and 2 volts here, and then I have 6 volts on that capacitor. So if I want to know the energy stored on C4, C4 was this capacitor. Energy is 1/2 CV squared. That's 1/2 of 2 microfarads times 2 volts squared. That's equal to 4 joules. Those are the answers. Now one more circuit to do. First, what is the equivalent resistance? Let's see, I'll draw the circuits up here. I'll just start them up here. I have my 2 ohm resistor. These two combined to give me a 4 ohm resistor. These two combine to give me 2 ohms. 1 over a third plus a 6 is equal to 2. That's 4 ohms, 2 ohms, and 2 ohms. That's 2 ohms. And then the 2 ohms give me 4. These two combine to be 4, and then 4 ohms gives me 4, and 4 in parallel is equivalent to 2 ohms. And so the equivalent resistance is 4 ohms. The current through R6, well, that's the current through this resistor, so we really just sort of need to find all the currents. I can first find this current, 12 volts. I will have 3 amps. I is equal to V divided by R, so that's 3 amps. That means I have 3 amps here. That means I have 6 volts and 6 volts. I do I times R to get me that. Although you could say, hey, I have 12-volt battery here split between 2 different resistors, so each of them has 6 volts. So I can start filling in some things that I have here. First of all, I know that this is 6 volts, and I know that it's 3 amps. Okay, these others I'm not so sure about, but I can go back to this circuit right here, and I know that this resistor has 6 volts, and then I know that these 2 resistors combined have 6 volts, so they're going to have 3 volts and 3 volts split between one another. So that gives me 3 volts here. That's the 2 ohm resistor on the right. And then I can also say, well, these have 3 volts and 3 volts because they're in parallel. Now, 6 volts across a 4 ohm resistor gives me a current of V over R, or 3/2 amps. All So if I have 3/2 amps, that means that I have a voltage, V equal I R, 3/2 times 3, that's 9/2 volts. And here, 3/2 volts. And 9/2 plus 3/2 is equal to 12/2 or 6 volts. Okay, so that's all my voltages. Now I'm looking for the current through R6. So that's right here. The current is V over R. That's going to be 3/2 amps. And then if I want to know the power dissipated across resistor R4, that's this one. I know V and R, and so power is equal to V squared over R. And so that's going to be 3 squared, 3 volts squared over 3 ohms, or 9 over 3, 9/3 watts. Okay, which is 3 watts, I'm sorry. So that's just 3. All right, let's move on to the multiple choice. Capacitor consists of 2 metal plates with an area 0.4. There's the distance separated, piece of paper, the dielectric constant, that's kappa. This is D. This is A. The capacitance is kappa epsilon naught A over D. It's 2.1, no units on that. Epsilon naught is 8.85, 10 to the minus 12. What is that? Farad over meters, farads per meter, the units. A is 0.4, and D is 2 times 10 to the minus 6. All right, so all right, I get 3.7 times 10 to the minus 6. That's going to be B. Parallel plate capacitor is connected to a battery with a potential of 12 volts. Capacitor remains connected to the battery. If it remains connected to the battery, that means that this voltage is constant. Initially has a charge of 24 microcoulombs. If the separation is doubled, what is the new value of the charge? So first, let's just think about what happens to the capacitance. I'm doubling the separation. That means the capacitance is halving. And since Q is equal to CV, I know this remains constant. If I have the capacitance, then I also have the charge. Whereas initially it had 24, now it's going to have a 12 microcoulombs. Consider this circuit. What is the potential across C1? Um, well, I know these two are 2 microfarads, and then a 2 and a 1 will be 3 microfarads, and so I have a circuit with 6 and 3, 12 volts. Now, you might be able to say right here, well, I know this has to be 4 volts and that has to be 8 volts. But if you're uncertain, then you would take one extra step. 6 and 3 in series is 2. That means that this capacitor has 24 microcoulombs, Q equals CV. That's 24 microcoulombs there and 24 microcoulombs there. V is equal to Q divided by C. So 24 divided by 6 is equal to 4. 24 divided by 3 is equal to 8. And so if I want to know the potential across C1, uh, that is going to be this, so 4 volts. D. What is the equivalent capacitance of this capacitor unit? 1 over 1 over 4 plus 1 over 4 plus 1 over 4 is 3 over 4, and so that's 4/3, inverse of 3 over 4. What is the voltage across the 1 microfarad capacitor? Um, well, I know the voltage has to be 3 times the voltage across the 3 microfarad capacitor, so I might be able to see that our voltages are going to be proportionate in that way. If not, I say 1 over 1 over 1 plus 1 over 3. That's 1 over 3/3 plus 4/3, or 3/4 microfarads. So it would have a charge on both of these equal to C times V, 3/4 times 12, which is 9 microcoulombs. So each of these will have 9 microcoulombs. And then to find the voltage is going to be Q divided by C, or B, 9 over 9. Where's the potential equal to 0? Okay, well I know it's not B, C, or D, because B, C, and D all have a, or excuse me, no, I'm sorry. I don't know that right off. But uh, B, C, and D are all equidistant between the positive and negative charges. So that since the negative charge is bigger, I know that each of these is going to have a negative potential because the negative charge will dominate. Over here, the 6Q is closer to E, so I know also this one, the 6Q will dominate. But over here, the distance from here to here is smaller than the distance from here to here. In fact, it's a factor of 3 smaller. And so the potential at point A will be equal to 0. Notice the distances. That this, if this distance is D, this distance appears to be 3 times that amount. And if it's 3 times that amount, that means that V equals KQ over R. I've doubled this or tripled this, and I've also tripled this, so they'll have the same potential. And so they'll cancel out since one's positive and one's negative. These lines are equipotential. If you have a proton at point A, which direction will it move? So you might be inclined to say that it moves down, like down a hill, right? Because if we think about a mountain, if I have a proton on a mountain, it's going to act, it's going to behave normally. But this isn't a mountain. This is a hole, right? And the proton is sitting right here. This is a potential well, and so it's going to remain stationary right there. Protons will move from high to low potential, but this guy is already at the lowest potential it can be, so it's going to remain stationary. It's a nice way to isolate a proton. Number 8, what is the potential difference between points A and E? So point A is right here, point E is right there. 14 minus negative 12, that's equal to 26 volts. Which of these represent the equivalent unit for amps? That's coulombs per second. You wish to measure current through a resistor, you should connect the ammeter in series with the resistor. What is the value of this resistor? So I find the slope of this graph is 5 over 20. So the slope is 1/4. And I know that I is equal to V over R. Or I could write it as I is equal to 1 over R times V. The slope is 1 over R, so 1 over 4 equals 1 over R, or R equals 4. Which provides the most light here? C is going to provide the most light because whatever voltage I have here, I get V over 2, V over 2. If I have that same voltage here, I just get V there. So this bulb is 4 times as bright as these bulbs. And here I get V and V, so I get twice the light I'd get for B. Which of these statements is correct? Bulb A is twice as bright as bulb B. Excuse me, no. That's not right. They're the same brightness. Because if this is V, this is V over 2, this is V over 2, and this is V. Bulb A is 1/4 as bright as bulb C. Well, I know bulb A is not as bright as bulb C. That one might be right. Let's just go on. I'm going to get rid of C here because I know that bulb A is not as bright. And I'm going to get rid of that one. So it's either A or D. Is it 1/4 or is it 1/2? Remember, P is equal to V squared over R. And so if I have a factor of a half here, that means that my power is 1/4. If I have half the voltage, I have 1/4 the power. So bulb A is 1/4 as bright as bulb C. A current 5 amps flows through a wire of length 2 meters across cross-sectional area 1.7. There's its potential. There's my current. From this table, select the material, the wire. So I just have to calculate the resistivity. First, I need the current. V is equal to IR. So I is equal to V over R. That's 10 over 5, or 2 amps. And then, excuse me, not I. R is V over I. That's 10 over 5, or 2 ohms. And then, since I know that R is equal to rho L over A, rho is equal to RA over L. So I have 2 ohms. Oh, shoot, keep writing amps. 2 ohms. Um, A is 1.7 times 10 to the minus 8 divided by the length, which is 2. So that cancels 1.7 times 10 to the minus 8. Copper is the right answer. Two pieces of copper wire, the same length. The diameter is twice that of wire B. How do the resistances compare? Well, you know what I like to do first of all? I like to just draw a picture because these things sometimes confuse me. But if I draw a picture of the two wires, this is wire A and this is wire B. So wire A, I know, is going to have a smaller resistance. It's just a bigger pipe, so it's easier to push charges through there. So wire A has a smaller resistance, so that means I can get rid of these options. So it's either half or a quarter. And since I'm talking about diameter, you might know already that it's going to be a quarter because I know that this is an inverse square relationship, right? R is equal to rho L over A. But I'm not given the area, I'm given the diameter. And I know that area is pi r squared, or pi diameter over 2 squared. And if I have, or excuse me, yeah, if I double my radius of wire A, then I'm going to get 4 times, excuse me, if I have it, if I have my radius, then I'm going to get 1/4 the resistance. All right, which of these has the biggest current? Doesn't matter what the voltage is, but all the current's going to go through R1. But look, R1's not an option. And then it's split up into 2 pieces here. I need to figure out which of these is the bigger of the 2 pieces. So this is 6 ohms up here, and this is 3 ohms down here. The 3 and the 6 combine to give me 2, and then 2 plus 1 is 3. So I get more current coming down through this bottom section. So it's either going to be if R6 is an option, it's going to be that. So it's, oh, it is R6. And I know R6 has a current that's bigger than R5 or R4. And I know R6 has a current bigger than R2 or R3. The voltage across R3 is 4 volts. What is the output voltage of the battery? All right, this is 2 ohms. This is 2 ohms. And I know this has 4 volts, so this must also have 4 volts. So that is 8 volts. For resistors in parallel, the equivalent resistance is always smaller than the smallest resistor. What is the total current for this? Well, I have 18 volts over 3 ohms. V over R is 6 amps. V over R is 3 amps. So the total is 6 plus 3, that's 9. And then circuits is your favorite thing to do now. All right.